So in this example, we'll discuss where the distance formula comes from. Here we have 2 points, A and B, drawn on a Cartesian plane. Now, if I project A downwards towards the x-axis and B downwards towards the x-axis, I would find the x value of A and the x value of B. And if I project point A towards the y-axis and point B towards the y-axis, I would find the y value of A and the y value of B. Now look carefully what I'm about to do. I'm going to draw in a triangle. Now this triangle is a right-angled triangle. And let's call this point C. Now if I use the properties of a right-angled triangle and I want to find the distance between A and B, ignoring all information on the Cartesian plane, I would say AB squared is equals to AC squared plus BC squared, which is Pythagoras. So just looking within the triangle, I can use the theorem of Pythagoras to find AB squared. But now, applying the information which we have, we can see that the distance of AC is represented by the difference between the x value of A and the x value of B. So this distance is x of B minus the x of A. And we can also see that the distance between B and C is the difference between the y value of B and the y value of A. So BC can be defined as y of B minus the y of A. Now, if I substitute these values of AC and BC into the theorem of Pythagoras, I have AC squared, which is xb minus the x of A squared, plus BC squared, which is y of B minus the y of A squared. And this still represents AB squared. And in order for us to find AB, we need to get rid of the square. So we take the square root on the left. And what we do on the left, we do on the right. Therefore, AB is equals to the square root of xb minus xa squared plus yb minus ya squared. And so the distance formula is simply an application of the theorem of Pythagoras. But you don't have to go the long route. You can simply use the distance formula in assignments, tests, and examinations to find the distance between 2 points.